So here are the key mistakes in the question of looking for U equaling to half V dot V. V cannot be dotted with V. V is not a vector. Neither can we have V as a vector. They can never be vector. E is equal to grad V is wrong because this one is a vector. Once this one is not put, when you don't put a vector here, then it is wrong because we know very well that grad V is carried by carry X, I plus carried by carry Y, J plus carried by carry Y, I mean carry Z. Okay, that's how strict I am. The diagram I drew it last time here. If you didn't put the forces there and you are trying to lie to me, trying to forge the forces, that F was this, you have to make sure you show me the forces clearly. So those of you who never, please, I need my clock. Agaba. The other mistake was the solution for the behavior of insulators and conductors in relation to the applied external electric field is actually on well. I've already uploaded the draft solutions. So you will get to know that all I wanted you to tell me is that when you apply an electric field for conductors, you have a flow of these free electrons. They flow freely in the conductor, whereas in an insulator, they are bound charges. They are bound to the atoms, and because they are bound to the atoms, they cannot do much movement at all. And but they can break down. Some insulators can break down if you have, an amount of about 10 to the power 9 volts per meter. If you apply such amount of electric field, you are bound to make an insulator break down. Some of you were saying that for insulators they cannot be polarized, but the conductors can be polarized. Not. They can both be polarized because we saw that when you put the electric within the plates or the capacitor, you get bound charges on the top and the bottom of these dielectrics, which if you got complaints, you can always float to my office with time. Wamala, don't be disappointed. You know what happened. Just because when you did take some details, I guess, somewhere, especially on the symbols concerning these E equal to minus grad V, when you said that, all these, like somebody was saying that grad squared divergence of V, this is wrong. That's how good I was. Just to make sure that we all move at the same pace. Okay, so let's now go to our example 2. So we look at the dielectric sphere in a uniform electric field. In a uniform electric field. Consider the calculation of the potential at any point for the case in which the dielectric sphere of radius A and permittivity epsilon, so let me use what you are used to, is placed in a uniform electric field. So let's have this field E being equal to E naught K, that is along the Z axis, which exists in free space, which exists in a region or in a medium of permittivity, epsilon naught. Hence, we would have that our V naught is equal to minus E naught Z, which is equal to minus E naught R cos theta in spherical coordinates. And this can be taken as minus E naught. We invoke the Legendre polynomials. So E naught R P 1 cos theta. So I'm going to be a bit quick because fighting against the time. So the total potential VR theta must satisfy. So we have our dielectric sphere, we have our field, and we're gonna be having a couple of conditions. So must satisfy the following conditions. And one, that VR theta will tend to be that for when you move to positive infinity. The other condition is that VR theta must be continuous at the interface of the dielectric being our sphere and the medium in which it is, which is having epsilon naught. So that interface, that on the surface of the sphere, the potential should be continuous. That is at the surface of the sphere, which is R is equal to N. 3, VR theta must be finite, must be a given value at the center of this sphere, dielectric sphere. 4, the normal component of the electric displacement vector D, must be continuous Now, I used to hear you by my ears, now I can even see you, so I can imagine the silence today. Continuous at R is equal to A. So, we shall recall the general solution, and this general solution was given that V So we recall that the general solution VR theta is equal to the summation as L equal to 0 to infinity into AL RL plus BA over R to the L plus, I don't want to call, I don't need to grab it because I always give it to you, into PL cos theta. So this one I always give it out if I have to ask such a question, that the potential, the general solution for potential in such kind of parts will be that. So I'm just trying to make sure that Makisaka understands already, knows what is going on with his efforts.
A few doors at this time, when it is not yet, when it is not yet 12, I wonder when it gets to 1.
So in order to satisfy the condition, in order to satisfy the condition 1, in order to satisfy this condition here, that as you move away from the sphere, you get the potential being V naught, the solution exterior to the sphere, the solution exterior to the sphere, that is, as you go far away from the sphere itself, must be of the form V exterior R theta is equal to V naught, the one which we already have as we are outside the sphere, plus summation from L is equal to 0 to infinity, then VL R to the minus L plus 1, PL cos theta. I hope I haven't jumped something to have reached that side. I might jump something. This thing may make me jump something and then I make you write things which are beyond. So I need to be very careful. So while the solution inertia, remember when we did for connecting sphere, we got two versions. We got I can't remember very well, but we had one which was showing that is the induced potential within the sphere, and then we got the next term showing that we are outside the sphere. So while the solution inertia to the sphere, that is where R is less than A, must be by using condition. Which condition do we use? Which of these conditions are able to help us to be within the sphere? When we have the center, when we have R is equal to 0, that's when we are less than the radius inertia to the sphere, and it must be condition 3, and will be of the form V inertia is equal to, of course, R theta is equal to V naught plus summation N is equal to 0 to infinity And then we have AL, R to the M, PL, cos. So in other words, if we expanded these two, this first term gives you the immediate. This second term, because we only raised this one, we wrote it as BL, R to the minus L plus 1, and then multiplied by each of them gets multiplied. So that's how we are getting. This first term here accounts for the immediate, and then this one accounts for exterior. Now that we are able to know how to figure out the immediate and the exterior, now we do the business. So according to condition 2, which I have wrapped, according to condition 2, so I can be smart and put them here, all the conditions, so that we are heavily informed about them. One is V R theta, need to poach on this sphere a little bit. So we have condition 1 as V R theta tending to D naught as you move away to positive infinity. 2, you have V R theta tending to continuous. So being continuous, as we get to the surface, 3, of course, V R theta was finite, is a given value at the center or within an area. Then we have 4. 4 we have D, D1n equaling to D2, n. That is continuity of the D. So, according to condition 2, we shall be able to discover that there are 2 solutions. There are 2 solutions, and these 2 solutions I shouldn't say there are. These 2 solutions, the immediate and exterior, these 2 solutions, so about that, must be equal. Must be equal because, you know, if we are using equation, condition 2, and we are talking of continuity, that V is continuous, so the immediate potential and exterior potential should be equal if we have continuity across the interface. And if they must be equal, this is at the surface, which is at R is equal to N, then we would have that our V exterior at R equal to N, and then theta. So instead of R theta, I'm putting N because I'm at the surface of the sphere, would be the same as V immediate A theta. So this is just an expression to show you that the immediate is equal to exterior because there is continuity across the interface. And this would imply that if I put in the values, the V's will cancel. They are both sides, so they can cancel out, so that I only remain with summation over L, BL, A to the minus L plus 1, PL, cos theta, equaling to summation over L, AL, A to the L, E, L cos theta. I've substituted for where there is R, I'm putting there A. And this would imply that the summations would not. I'm doing the same both sides, so together our AL is equal to BL A to the minus minus 2L plus 1. And I call this one equation 1 for this example. Since the Legendre polynomials are linearly independent, what does it mean by being linearly independent? You visit mathematics. Linearly independent the coefficients of the PL cos theta must be equal. So if they are equal, and we also recall that the electric field density is given by E is equal to minus grad V, then we can now move forward to getting a few things, more things like we get potential, we can use that to get the electric field density, we can go further and get the surface charge, the charge density, EDC. So take our E equal to minus grad V in spherical coordinates, you know that grad V in spherical coordinates is one of, anyone remember? This is the identity section of the test. You will see this. So E external, the external component of the ER will be equal to minus Kali V external by Kali R. And then we can have the we equated this, these two coefficients because of if Legendre polynomials have to be linearly independent, then the coefficients have to be equal. So I will get, if I do the integration, I mean the differentiation, I'll get this implying that E exterior R would equal to E naught PL cos theta plus summation over L plus 1 BL R to minus L plus 2 or 2 plus L PL cos theta. I guess there might be an issue to solve here. Most probably, or I think that's okay. Any questions? I know I'm a bit speedy, but I want to finish this example. Otherwise, I will say finish it from where, but it would be nice if we could finish it together here. Okay, so I get the that being for external, and the E in area R would be equal to, so I can arrange them nicely. E in area R would be equal to minus Kali V in area by Kali R, implying that E in area R would be equal to E naught PL cos theta minus summation over L, L in AL, L minus 1, PL cos theta. Do these differentiations when you are in your free time to be able to have comfort, to be comfortable with the indices which I'm putting now. But from the other condition, from condition 4, but from condition 4 there, d1n, the normal component of the electric displacement vector, which is d1n. And those of you who will find I cancelled the number where you will say d1 cos theta is equal to d2 cos theta 2, theta 1 here. This is wrong because the cos is coming simply because you are taking the d dot n. Their product, this is 1, so that's when you get the magnitude of this times the magnitude of this, which is 1 cosine of the angle between them. Because you drew the diagram very nicely, say this is the inner face, and after getting this as the inner face, you say this is the N1, 2 for this being medium 1, medium 2, the epsilon 2, epsilon 1, and having your D, D2 and E2, D1 and E1, and having your theta 1 and theta 2. So what you are trying to get is the normal component, which is that in the D1 and the N. Their magnitudes is D and 1 because it is unity. The N roof is the unit direction vector. So you put this, I cancel, and never can you have D sine theta. Because the sine comes in because you are taking the tangential component. So D1n is equal to D2n for continuity across the inner face, and we know that D is equal to epsilon A. Thus, if we now know these facts, if you go to Boas, Mathematical Methods for Physicists by Boas, if I have pronounced it well, you'll be able to see how mathematical physics is relevant to problems in physics, especially in this part of Legendre, polynomial special functions, and how you need, why you need mathematics in physics. So in order to satisfy condition 4, in order to satisfy condition 4, we have used it, but in order to satisfy this condition 4, we must have, already I had, we must have, of course, I've already done it, but I have to review it, is equal to D2n. So this implies that epsilon naught E exterior R at the surface should be equal to epsilon 1. Did we say epsilon 1 or epsilon? So should we put it as epsilon 1 or leave it as epsilon? Pardon? Yeah, I hope I will have no trouble remembering whether it is 1 or 2. So epsilon, let's take it as epsilon. And then exterior, I mean, this one is inside. This is the permittivity of the dielectric, which is our sphere. So this would be E in area R, and this should be, of course, at the inner face, which is R is equal to Ganira. It will be fine, don't worry. Which is at the surface of the sphere. So let's now do our business. gymnastics. So epsilon naught into E naught PL cos theta plus, I'm just now invoking these two parts, these two expressions, this one here and this one here. I'm now making sure that because if D1n is equal to D2n, basically we are saying that these two multiplied by epsilons will be equal to D. So the two should be equal. And then of course, when you take the cos the other side and the cos this side, so this is E naught PL cos theta plus L, then L plus 1 into BL, then R to the minus L plus 2, the other one above, PL cos theta, do I need more space? Should be equal to this other one. So I need more space definitely. Can I put it here? Okay, so this would be equal to C below, that is epsilon into the E in area, so which is E naught PL cos theta, and then I subtract summation over L, then L into AL to the R to the L minus 1 PL cos theta. So equating the coefficients, yes please. Equating, this one is for interior, we are multiplying by the epsilon. For the exterior, we are multiplying by the epsilon naught, because that is the milieu in which this is inside the sphere. This epsilon naught is outside the sphere. So now, if we equate the coefficients, equating coefficients of corresponding powers, I don't know simply it's called, of our Legendre polynomials, then we obtain, I will have to utilize this space since we have almost utilized all that was written here. It comes out easily when in your free time you start doing these differentiations of E exterior R equivalent minus grad V exterior dr, and when you also do the E interior R V minus grad V interior dr. Once you do those in your free time, you'll be able to have these things. So we're able to obtain that B A minus 2 is equal to 0 for when we take L equal to 0. So this is our equation 2. Or do I use Romans, or I can use numerals? So I had put 1, you can put, I had put this, but you can now put that. And we shall also have that epsilon naught into E naught plus 2B1 a to the minus 3 will be equal to epsilon into E naught minus A1 for L equal to 1. So now you have somehow an idea of how we argued last time, or how we discussed last time, the implication of the L. Is L, what is the representation of L? For here, we are now having L equal to 0. And we are having that assumption in the first place, and also L equal to 1. So you have now an idea that L is not the number of field lines or the like. So that's still something I want you to venture into. So once we got this, then it would be that, and in the nuts, the epsilon is epsilon 1. So in the nuts, on whether this is epsilon 1, the one inside, but why should I have 1 and nut when I can just leave the other one just epsilon? So it doesn't matter. Yes? B? B not.
Just like you have A1. Is it not a B since it was BA?
Here? Here?
Yes.
I think so, but I have to first check. I want to be sure, yeah. It is just my typological. Is it a slip of the hand? The hand was the one writing. So also we would have another order where we have epsilon naught into L plus 1, then BL A to the minus L plus 2, which should be equal to epsilon into minus L, AL, then A to the L minus 1. And this is for L greater than 1. And I call this one equation 4. So using are we together? Because these people normally come and hustle me up, I will say that complete this from where, nevertheless, tomorrow I can begin from there, and since there is a real part to finish, I can utilize coaching into your lunchtime, and then I'm able to complete the work. The rest now is just algebraic gymnastics.